October 29th, 2019. An interstellar object named 3I Atlas reached its perihelion, the closest point to the Sun in its long journey. Dozens of observatories worldwide trained their telescopes on it, anticipating to capture a spectacular cometary event. Yet the phenomena we observed contradicted all our theoretical models. Before delving deeper, allow me to pose a question. Do you believe an object originating beyond our solar system could consciously control its own movements? Share your thoughts in the comments. Yes or no? Your answer may change after watching this video. Also, tell us which country you're watching from. If you're fascinated by the mysteries of the universe, don't forget to like and subscribe to our channel. We've witnessed unprecedented global attention on this object, and this fascination stems precisely from its profoundly perplexing behavior. Perihelion marks the most active phase for comets. At this point, solar radiation reaches its peak intensity. The icy material within the comet nucleus sublimates massively, forming a vast coma and tail. We have observed thousands of comets, all adhering to this predictable physical pattern. Yet 3I Atlas defied this expectation. At a mere 0.7 astronomical units from the Sun, it entered Mercury's orbital range. Something extraordinary occurred. Its activity did not intensify as anticipated, but instead ceased entirely. Its coma began to diminish, and its overall brightness plummeted by 40% within just 6 hours. This phenomenon directly contradicts fundamental thermodynamic principles. Consider the implications. The strongest solar radiation should trigger the most intense activity. Surface temperatures on the comet nucleus should skyrocket, causing rapid evaporation of subsurface volatiles. Yet what we observed was a shutdown of activity, as if the object detected the increased radiation intensity and correspondingly reduced its own material output. Natural objects lack self-regulating capabilities. Rocks and ice lack intrinsic feedback systems. They do not make decisions based on external environmental conditions. Yet the data suggests 3I Atlas may be doing precisely that. This is merely the beginning of a series of anomalies we face. In the following video, we will examine each piece of data challenging our understanding. This evidence will lead us toward a startling possibility. What we may be studying is not an ordinary comet. To grasp the true extraordinary nature of 3I Atlas, we must delve into its most fundamental physical properties, the very scientific basis for identifying any celestial body. Yet for this interstellar visitor, every piece of evidence points to perplexing paradoxes. First, let's analyze its unique spectral signature. Spectral analysis is the cornerstone technique in astronomy for identifying material composition. By observing the intensity of light reflected or emitted by an object across different wavelengths, we can decipher its chemical fingerprint of constituent elements. Dr. Robert Warwick's team at the University of Hawaii conducted 12 hours of continuous spectral observations of 3I Atlas. They compared the acquired data against an extensive database containing all known molecular signatures. This repository encompasses countless spectra from asteroid, comet, and meteorite samples. The results were startling. No known spectral features matched the observations. Within 3I Atlas's spectrum emerged entirely novel emission lines. These lines indicated helium compounds and structurally unique hydrocarbons. These had never before been detected on natural celestial bodies. More unsettlingly, certain specific wavelengths could not be correlated with any stable known molecular structure. The research team was forced to acknowledge two possibilities. Either we were observing a peculiar chemistry that does not exist in nature and can only briefly exist under extreme laboratory conditions, or what we were seeing was not a chemical reaction at all. Next came its counterintuitive thermal distribution characteristics. Any irregular rocky body exposed to solar radiation exhibits significant surface temperature variations. Sun-facing regions reach the highest temperatures, while shaded areas remain cooler. Different materials possess varying thermal capacities and heat absorption efficiencies, resulting in distinct hotspots and cold zones on the surface. However, infrared observations of 3I Atlas reveal a perfectly balanced temperature distribution across its entire visible surface. Under intense solar radiation, it behaves like a thermally uniform sphere. This suggests two starkly different possibilities. Either the object is composed of some unimaginably homogeneous material, which directly contradicts our previously obtained spectral data, as the spectrum clearly indicates the presence of multiple distinct substances on its surface, or the object possesses some active thermal distribution system internally capable of continuously transferring heat from hotter to colder regions, thereby maintaining overall thermal equilibrium. This characteristic requiring active internal energy regulation is entirely unrelated to any natural celestial body within our understanding. Finally, let us examine its rapidly fluctuating albedo. Albedo measures an object's surface ability to reflect sunlight. It is primarily determined by surface chemical composition and physical texture. For natural celestial bodies, these properties are typically stable, with changes occurring extremely slowly. However, during its perihelion passage, 3I Atlas's albedo surged from 0.04 to 0.09 in less than 8 hours. This signifies that its ability to reflect sunlight more than doubled within an extremely short time frame. Considering this change from a physical perspective, to significantly alter an object's albedo, you would need to change the properties of a substantial portion of its surface. For instance, geological activity exposing fresh ice layers from beneath could make it brighter, or the eruption depositing dark dust could make it dimmer. But the crucial question is that while 3I Atlas experienced a sharp increase in albedo, its material volatilization activity was suppressed. Natural logic cannot explain this contradiction. Exposing ice layers inevitably involves significant gas release, while depositing dust typically requires active jets. It appears capable of autonomously controlling its surface optical properties, with this control precisely synchronized to its activity level regulation. Synthesizing these paradoxical physical characteristics, we confront an object whose chemical composition, thermodynamics, and optical properties completely transcend our existing knowledge framework. These anomalies do not exist in isolation, but interconnect to paint an extraordinarily unusual picture. In the next section, we shall delve deeper to examine further enigmas in its energy and dynamics. This evidence will further challenge the boundaries of our understanding of the natural cosmos. If the anomalies in 3I Atlas's physical properties were already perplexing, then its behavior in energy release and motion patterns has utterly transported us into uncharted territory. These phenomena are no longer contradictions in static attributes, but anomalies in dynamic processes. They strongly suggest the potential existence of some form of operation within it. First, let us examine its pulsating magnetic field. As 3I Atlas transited perihelion, NASA's Parker Solar Probe, passing nearby, conducted a high-precision magnetometer scan. The findings exceeded all expectations. From a distance of 2 million kilometers, the probe clearly detected a localized magnetic field emanating from 3I Atlas itself. This was not the typical faint, disordered magnetic field common to comets, generated by the interaction of ionized gas with the solar wind. Instead, it was a field with a distinct structure and specific pattern. Its field strength reached 0.3 nanoteslas. For an object only about 400 meters in diameter, generating a detectable magnetic field at such a great distance requires extremely special internal conditions. Either its interior contains a large amount of ferromagnetic material arranged in a special configuration, which is exceedingly rare in celestial formation, or it harbors continuously flowing electric currents. Both scenarios far exceed expectations for an inert mass of rock and ice. Yet the most unsettling detail for researchers is that this magnetic field exhibits strictly periodic oscillations emitting regular pulses with a 47-second cycle. Natural celestial bodies' magnetic fields do not oscillate with such precise, clock-like regularity. Pulsars do emit regular radio pulses, but those are massive neutron stars spinning at high speeds whose physical scale and density are incomparable to 3I Atlas. The presence of a pulsating magnetic field in a small object necessarily implies the existence of circulating or fluctuating currents within it. This dynamic electrical activity directly points to active internal processes, a characteristic we would never associate with natural phenomena. More direct evidence comes from its inexplicable orbital corrections. Since its discovery, global space surveillance networks have tracked 3I Atlas's trajectory with extreme precision. Our orbital calculation models have accounted for all known physical factors. The sun's powerful gravitational pull, gravitational perturbations from planets, the minute pressure exerted by solar radiation, and even the theoretical thrust from extremely faint gas volatilization. After perihelion, the predicted orbit calculated from all these parameters shows a non-negligible deviation from the actual observed orbit. The object deviated from its expected position by a full 800 kilometers. Natural explanations capable of causing such orbital changes are extremely limited. The most probable cause is a violent ejection of material similar to rocket propellant, the expulsion of a large mass in a specific direction to generate recoil force and alter the orbit. However, despite employing all observational methods, no associated material jet has been detected. The object appears to have autonomously adjusted its path without any visible propulsion signs. Another possible explanation is a gravitational interaction with an unknown low-mass celestial body that remains undetected by our instruments. However, within our intensively monitored observation range, this possibility is extremely remote. After ruling out these natural factors, the remaining possibilities become profoundly astonishing. This object may be employing some propulsion mechanism beyond our direct observational capabilities. Combining magnetic field anomalies with orbital deviations reveals a distinct pattern, an object capable of generating internal currents and modulating its magnetic field. An object capable of altering its motion without discernible material ejection. These behaviors collectively point to energy conversion and propulsion control. Characteristics of a functional system, not random behavior of a natural celestial body. In the next section, we confront the ultimate interrogation, compiling all evidence chains to seriously explore that unsettling yet thrilling hypothesis. What exactly is 3I Atlas? And how should we respond to all that this discovery implies? Faced with so many anomalies that defy satisfactory explanation by existing theories, the scientific community is compelled to consider every possible explanation, no matter how improbable it may sound. Current views on the nature of 3I Atlas have largely split into two distinct camps. One points to intelligent design beyond human comprehension. The other insists on seeking answers within unknown natural realms. Let us first examine the artificial origin hypothesis. This theory posits that 3I Atlas is not a natural celestial body, but rather an artifact created by an extraterrestrial civilization. Within this framework, several primary inferences emerge. The first is the fully functional probe hypothesis. It may be an operational scientific reconnaissance platform whose anomalous behavior at perihelion represents deliberate, programmed responses, such as systematically collecting stellar data, testing performance under extreme conditions, or even evaluating planets within our life-bearing, technologically advanced solar system. Its self-regulation and trajectory corrections exemplify its advanced engineering capabilities. The second is the ancient artifact or cosmic archaeological relic hypothesis. It may be a probe launched millions of years ago by an extinct civilization, now aimlessly executing pre-programmed automated tasks. The contradictory behavior we observe may stem from partial system malfunction, as it attempts to execute a task it no longer fully comprehends or can flawlessly complete, much like a robot that has lost its programming instructions. The third hypothesis is intentional contact. It could be a communication beacon designed for preliminary contact whose deliberately engineered anomalous behavior aims to capture our attention and provoke thought while avoiding overt directness that might trigger panic. By demonstrating physical properties defying natural laws to convey a clear message, we are not alone. Yet this hypothesis also faces scrutiny. If contact is the intent, why not employ more unambiguous communication methods, such as regular radio signals? For scientific rigor, we must equally examine the natural phenomenon hypothesis. This theory maintains that 3I Atlas is an unprecedentedly peculiar comet. All its anomalies can be explained by extreme natural conditions we have yet to fully comprehend. Regarding its diminished activity at perihelion, researchers have proposed a thermal lag and crust sealing model. This model posits that the comet nucleus consists of highly insulating, fluffy material. Heat absorbed by the surface takes a long time to conduct to the volatile-rich interior. Simultaneously, initial heating may cause surface dust to sinter and fuse, forming a temporary hard crust that effectively seals the internal gases. until internal pressure builds sufficiently to breach the crust. Regarding its uniform surface temperature, a rapid rotation and internal convection model has been proposed. If the nucleus rotates faster than our measurements indicate or possesses a porous interior, allowing gas circulation, heat could be efficiently distributed across the entire surface. Though this model faces physical challenges regarding its rapidly changing albedo, surface chemical changes and frost deposition models offer some explanation. Perhaps intense ultraviolet radiation triggers photochemical reactions in surface carbon compounds, forming a highly reflective coating. Or within the microenvironment surrounding the nucleus, special temperature and pressure conditions exist that our models fail to capture, allowing water vapor to directly sublimate into frost on the surface. Regarding its pulsating magnetic field, the primordial metal core and thermal current model is a bold proposal. This model posits that 3I Atlas retains a tiny metallic core from the debris of a destroyed protoplanet. When temperature gradients develop within this core due to solar heating, weak internal currents may generate a magnetic field. Its pulsations could correlate with the nucleus's oscillations or periodic thermal stresses in its interior. We must acknowledge that every natural explanation model faces significant challenges. Each may barely account for one or two anomalies, but when demanding a unified model to explain all anomalies simultaneously, including spectral chemistry, thermal distribution, albedo, magnetic field, and orbital deviation, natural hypotheses prove inadequate. Their probability, as stated by a senior scientist, approaches statistical impossibility. The prevailing stance within the scientific community remains conservative. Official bodies emphasize that no conclusive evidence exists to establish an artificial origin. They urge maintaining an open-minded approach while upholding stricter standards of proof. Yet in informal discussions, many researchers privately acknowledge that the directionality of the data is profoundly unsettling. We stand at a crossroads of scientific paradigms. One path offers the comfort of continuing our existing worldview. The other is a narrow, awe-inspiring yet uncertain path into the unknown. In the next and final chapter, we will explore the profound implications of this discovery for human society and the urgent choices facing us as a species. The analysis of all data ultimately brings us to a crossroads. What we now confront is no longer merely a scientific question, but a philosophical choice concerning the vision and courage of human civilization. 3I Atlas is moving away from the sun at 20 kilometers per second. It will not wait for the outcome of our debates. Each passing day means it drifts 72,000 kilometers farther from us. Every month of delay multiplies the difficulty of a potential interception mission. We are watching what may be the most significant discovery in human history slipping through our fingers. The journey of scientific exploration is always accompanied by uncertainty. But true progress stems from our courage to confront the unknown and take action. Currently, space agencies from multiple nations are conducting feasibility studies for missions. China, with its ambition and efficiency in deep space exploration, is seen as a strong contender. Relevant teams in the United States are lobbying for emergency funding. Europe and Japan may participate through international collaboration. Yet all these plans remain trapped in bureaucratic deliberations, budget allocation games, and concerns over the potential societal impact of a groundbreaking discovery. We possess the technical capability to launch a flyby probe within years, and could potentially achieve sample return within a decade. What we lack is not technology, but the collective will to make the decision. Imagine two possible futures. In the first, we choose caution and silence. We continue observing it from distant ground-based telescopes, publishing more papers but never sending a spacecraft. The signal from 3I Atlas eventually fades into the darkness of interstellar space, becoming an unsolved mystery in the history books of future generations. An eternal regret of having been so close to the answer, yet missing it through timidity. In the second future, we gather consensus and courage. The global scientific community unites in a powerful call. National agencies set aside differences to jointly launch an emergency probe mission. A spacecraft equipped with high-resolution cameras, spectrometers, and particle analyzers is launched into deep space by a rocket, ultimately catching up to this mysterious visitor. When the first clear images and data reached Earth, human history was forever divided into two eras. Before this, we were a species living alone on a pale blue dot. After this, we knew we were not the only sentient beings in the cosmos. Whether the probe revealed an artifact engraved with alien symbols or a natural wonder beyond our imagination, we had won. For we would move from ignorance to knowledge, from conjecture to truth. This was the ultimate revelation left to us by 3i Atlas. Like a mirror, it reflected humanity's own image. Are we curious, courageous explorers, forever dissatisfied with the status quo? Or children bound by fear and inertia, trapped within our own cradle? The cosmos is not silent. It has already sent us a message. This message is encoded in the 3i Atlas's defiance of conventional wisdom. Now it is our turn to respond. Our response will define our generation's place in the long river of human history. Will we choose to embrace a broader, more wondrous universe? Or will we turn away and continue pretending we are the only intelligent life? This choice is not in someone else's hands. It is in yours and mine. It lies in the voices we raise, in the knowledge we share, in the actions we collectively inspire. If the cosmic wonders explored on this channel have moved you, turn that awe into action. Discuss, advocate, and help those around you understand the significance of 3i Atlas. For the destiny of exploring the unknown is always written by all who gaze upon the stars. Thank you for watching until our next mission.